Good evening everybody and welcome to another Stealthness coding. Today I'm going to show you how we can remove boilerplate code using Project Lombok. And I'm going to show you Project Lombok without the use of an IDE. So first of all we're going to show you what boilerplate code actually is and then show how we can remove it using Project Lombok. Here I've already created two very simple Java files. I've got a person class which has three fields, a first name, last name and an age, and I've got another Java source file that's basically going to run a simple program that's going to create an object of person class, and then it's going to print out the toString method of that. And since there isn't actually a toString method in the person class, it will use the default toString method from object class, because all Java classes are derived from the object class, which is the basic building block of a Java class. So without further ado, let's compile these classes and see what they're doing currently. So we're going to move ourselves to where I have my currently files. And if I do a tree on this, it will show that I've got my two Java files. They're in the source directory, and I'm going to compile them, and make the compiled classes go into the alt directory. So for that I use the java-act command. I'm going to use /d to select the destination, in this case is alt. I know that they're all in the location of the source file, and I'm going to use the WildStar thing to allow me to compile all files that are .java in that, so I don't have to type out each one name. And if I do tree now here, I will see that I have my two classes have been compiled, person.class and testperson. So if I want to run it from here, I have to do if I try to just run testperson here, first of all it doesn't even allow me to autocomplete because it can't see it. And in actual fact I'll get an error, I can't load, because it doesn't actually know where it is. What I have to do is I have to add to the class path the location of where these are, and that's in alt. And there you can see it can autocomplete because it looks in there and it finds the test person class, so it knows it's there. And when we run the person, we can see that the first line here just prints out test person, and then on this line, after it's created the object, it does toString. And currently what it does, the object method of toString does, it prints out the class, which in this case is person, and then it supplies a location of where it's stored within the virtual machine memory. So that doesn't really tell us anything much. So let's actually do our own toString method for the person class. So we're going to override the toString method. It's public string because it returns a string. It's called toString. Takes no arguments. I'm going to return. And what I'm going to return is I'm going to return whatever the first name is. This returns to the object, and it says this.firstName, so we're returning the value that is stored in the private string because it's private, but because this is a method within the class we can access it, and it will just return that. So we save that, and now we run our commands again to compile both. And if we run this again, we can see now that we have test person, and when we print out the next value it prints out null, and that's because we've not actually set a value for the first name. Now it could be set at constructor time, but currently at the moment I don't have a constructor in person, so it uses just the default constructor from object. So here I'm also going to announce what's called a setter method. I'm going to set the value for the first name. So it's going to be public, it's going to be void because it doesn't actually need to return anything. We're to set first name, and it will take in the argument of a string, and that will be the first name. Now, to differentiate between the local variable that's created called first name and the member field first name for the object, we use the keyword this, first name equal to first name, and we save that up. So now we've created a setter, it will just take the thing. So when we go back to here, we can now actually use p.set first name, and we're going to set it to Bob. So we save both of those, and we rerun our commands. And there we see that we've got test name, first name is set to Bob. But then of course if I wanted to do this for the first name, last name and so forth, I'd have to go back and I'd have to set write methods to do that. So I'd have a set first name, set last name, set age, and I would also have get first name, get last name, get age if I wish to actually also get those values. And that's already 6 methods, as well as the toString method, and this is all what's known as boilerplate code. Now, we could of course use an IDE to generate this, and many of them do. Many of them allow you just to click on the field value and it will allow you an option to generate these automatically. But we're going to use something a bit different. We're going to use another set of Java classes that are located in the thing into the project Lombok, which we're going to add to our thing. So the first thing we need to do is obviously download this, and if you do a simple search of Project Lombok, then you will come to this selection. You click on that, then click on the download, obviously download it, then you can obviously take that jar file that you will download and you can move it to your location. Now in this case where I have put it, I have put Project Lombok here, and you can see the jar file there, and the jar file is just a compressed file full of Java classes. So now I'm going to go back to here, and the way we do this, we're going to import Lombok, and the first thing I'm going to remove is I'm going to remove the set first name. So I'm going to use a method setter from Lombok, and the way that I do that is I add to the above the field first name, I'm going to add this annotation setter. So now I don't need this anymore, so I'm going to save that. Okay, I don't need to change this other one. Now if I was to compile this without actually making one suggestion, it's going to give me an error. And the reason it's going to give me an error is because it actually doesn't know what Lombok is. I haven't told it where to find Lombok. So because it can't find Lombok, it can't find setter, and of course in the other file when it tries to compile the other one, it no longer sees a set first name, and so it can't compile that. So what I've got to do is I've got to add to the class path using -cp the location of our Lombok jar, and so for that I will add its location, and one thing that is often forgotten, that it's not, can't just add the location of where the Lombok jar is located, but you must also include on the name the actual lombok.jar, because the class files are actually located within that compressed file. Okay, now I need to check what I've done wrong. package doesn't exist. And that's because I missed a file. It's actually located in Lombok folder. And there we go, it's compiled. So now if I actually run this, apologies, I pressed the wrong, selected the wrong command there. No, so if I run this, I now see that the setter method has now created a setter method for the first name. So I didn't need to configure that, and it says test person, first name is Bob. But there's also other methods. I can also actually create a default, the Lombok default toString. So here I'm going to import Lombok toString, and here I add the annotation just before the class toString. So I don't need this piece of code anymore. So I'm going to save that. So running my commands again, compiling both, running them, and now I can see that the Lombok toString method gives us a lot more information. It tells us the class, it also tells us the value of each of the fields. In this case we've got first name is equal to Bob, last name is equal to null, and age is equal to 0. Age is equal to 0 because it's a primitive and so it has a default value, whereas the last name and first names are strings, and these are object classes, and they are basically null because they're not referenced by anything. So there is a way that we can also, without having to use a setter on each one, we can actually do a one command that can do both the setter and the toString all in one go, and we're going to use a command called data. And what this is going to do is it's going to give us all the getters and setters and the toString and a few other methods that I haven't mentioned as yet. So if I now save this, run it again, now it's giving us the same value, and that's because I haven't actually changed those values as yet. So b dot set last name, let's call it Bob Hope, and he lived to a good old age, so we'll set 100. So if I now save that, compiling them all again and running them, and there we have it. We've set the person to Bob, last name is Hope, and his age is 100. And our class is very, very simple. We didn't have to write any of that boilerplate of set age, set first name, set last name, get last name, get first age. It's all there in very simple, and that's basically the power of Lombok. And there's many other different functions in there, and it's definitely to be explored thing. So I hope you like this video, and I hope that you've got some instruction. Comments are always welcome below, and thank you very much for listening.